Polynomial means usually when we start with the polynomial, we start with the definition of constant and variable. You know the difference of constant and variable? We played a game, remember? What was the game? You think of a number that like we played one game, remember? Shall we do it once again? You don't remember? Okay then. See, just follow my instruction. You think of a number. You thought of number, right? Very simple or big number also you can think, not a problem. You thought or not? Okay. And double the number. Have you doubled it? Okay. Now add 7 to the number. Subtract the number that you initially thought once. From the result, you have to subtract the original number. Okay. And then add 5 to the result. Have you added 5 to the result? Now again subtract the original number. Now all of you got your answer as 12. Is it same for everyone? How does it happen? Shall we do it once again? You try to crack it if possible. You are saying something? Okay. He went offline. Okay, once again. Think of a number, any number. Add 6 to the number. Okay. And then again add the original number. Now add 5 to the result. Subtract the original number once. Add 2 to the result. Again subtract the original number. Now all of you got 13 as your answer. Am I right? That is it. How it is happening? See, when I say think of a number, you will be thinking different numbers. I may not aware of that. What is in my control? Some constant values. Whatever the number you thought is variable. It varies person to person, right? You may think the different number, she may think different number. Likewise, it differs. But when I say some numbers, 6, 5, 2 and all, it's constant. On the go, on the process, I just eliminated your variable. That's all. Okay. That is how the constant and the variable works. Okay. So constant is a number common for everyone. Variable is differs person to person. So when we have a combination of variable and constants, we can do numerous things. Numerous things in the sense either we can multiply two constants. Likewise, we'll multiply two variables or variable with the constant. Likewise, many things we'll do. In that, we can write like more than one variable also we can take. Like x, y, x, z, a, b, c. Likewise, we take many variables. We multiply 1, 2, 3 with it. Okay. Then we'll express that as a expression. We are expressing things, right? So that is called algebraic expression. Why it is called algebraic expression? We are expressing something. You don't know about something, but what you got is 2 more than that. For example, I'll give you 2 more chocolates than your roll number. How will you express? How many chocolate each person can get? That should be expressed in a unique way. I'm going to give you 2 more chocolates than your roll number. So roll number is a variable or 2 is a variable. Which is variable here? Your roll numbers. Let this be x. Whatever we don't know, we'll keep it as x. So each person will do x plus 2. So what you will do here? You will put your roll number here and then plus 2. It varies person to person. So all together we can express as one expression, that is called algebraic expression. So in this way of expression, there are many things are there. One variable is there, two variable is there. We can multiply variable with constant, many things. So that kind of things is called as multinomial. Multinomial means it's a combination of variable and constant multiplied together as many terms it may have. For example, x square plus 2xy plus 3 by x plus 4 by y plus 7y square, whatever it may be, will be as many variables it can have, as many constants it may have, as many terms it may have. Okay, now we are going to classify it by applying a certain restriction to the multinomial. We are going to define polynomial. It's a just altered version. When you see this expression here, x square power is 2, here power is 1 is there. Here what is the power of the variable? If you put that in the general form, it is -1, y power also -1. Sometimes root x, root y also will be there. That is also a multinomial only. Okay, so this kind of irrational powers, negative powers and all we couldn't handle. Okay, what if it is a whole number? What if it is a whole number? I'm just checking whether you're listening or not. Whole number means could be neat, right? Like easily we can write. So if in a multinomial the powers of a variable is a whole number, then it is called a polynomial. And we are going to discuss about polynomial in one variable. Okay, all this may sounds like unwanted detail for you, but everything does matters here. Okay, this is the origin of the polynomial. And then in one variable, here many variable we used, so it should be in one variable. Also the power should be whole number, that like we should express. So we have this a0 plus a1x plus a2x square plus and so on an exponent, like we can express this. So like a general form I have given. What are these a0, a1 and all? a0, a1, a2 up to an, all are constants, and this n is a whole number, not natural, can be whole number. Why? Because here 0 is included. Okay, got it? Okay, how we are denoting this? All the time this much big like shall we denote? No. So we should give a polynomial name, that is p of x. Why I used to p of x? First letter of polynomial. Okay, of x means it's a polynomial in x. Okay, likewise q of y if I say means, what does that mean? The name of the polynomial is q and that has what variable? Y as their variable. Okay, and this classification and all we have studied in 9th class itself, remember? So based on terms we have classified quickly. Based on terms, how we classified this, you remember? When there is only one term, monomial. Only one term means monomial. Two terms, binomial. Three terms, trinomial. Four terms, it's a polynomial, that's all. Okay, clear? And there is a, when you say multinomial, we can compare this. See, shall we say all the multinomials are polynomials? Is that true? No, we should not. All the polynomials are multinomial. Will that be true? Possible? Okay. See, All the polynomials are multiple. We studied in 9th class only. This may be used in 10th class as well. Okay, we don't know where it will be used. And then here based on terms we splitted, and then degree of a polynomial, you know, degree of a polynomial, the highest power of a variable exists in a polynomial. That is called degree of a polynomial. Okay, so based on degree also we can classify. When the degree is 0, how will you call that polynomial? Remember, it is a constant polynomial. It's a constant polynomial. When the degree is 1, how do we call it? Remember, linear polynomial. When the degree is 2, it is quadratic. When the degree is 3, cubic. When the degree is 4, biquadratic. When the degree is 5, pentic. Polynomial of degree 5 or else pentic shall we say. 6 means hextic. 7 means septic or hectic. Oh, no, not hectic, heptic. Hept or sept. Okay. And then 8 means octic, 9 means nanic, 10 means decic. Okay. 11 means 10 means decic, 11 means 12 means duodecic. Likewise, it is there. There are naming things. Okay. So whatever, these are all the things we know about the polynomials. Okay. And in this chapter, now only we are getting into 10th class what we discussed. How to represent this polynomial as a graph. Especially we will be dealing about only quadratic polynomial here. Quadratic means it is of degree 2. Okay. So the general form of quadratic polynomial. What is the general form of quadratic polynomial? So it is ax square plus bx plus c. It is not the general form. P of x is equal to ax square plus bx plus c, in which a should not be equals to 0. Okay. The leading coefficient should not be equal to 0. So this a, b, c are coefficients. You know about coefficients, right? Coefficient means what? First of all, co means what? You have this word before, co. Vasant and co, you remember? What does that co means? Company. Vasant and company. Okay. Likewise, here coefficient of x, if I say, means who is accompanying x. Okay. So coefficient, who is accompanying x. Who is accompanying x in the polynomial? It is b. Okay. Likewise, coefficient of x square, if we say, means who is accompanying x square? A. Then how do we call it? There is no x, no one is accompanying him. He is a constant term. Okay. Got it? Okay. Next, the number of zeros. Number of zeros of a polynomial. Does it start with the number of zeros? Yes. The zeros of a polynomial we should see first.